Does time-restricted eating affect cognitive performance and mood? The cognitive implications of dietary interventions rarely receive the attention they deserve, yet mental performance and emotional well-being represent critical outcomes for any intervention intended for widespread adoption. Time-restricted eating, despite its metabolic focus, operates through circadian mechanisms with direct neural connections, raising legitimate questions about how compressed eating windows affect brain function, mood stability, and cognitive capacity. The limited research addressing these questions reveals a complex picture where timing, individual differences, and adaptation interact to produce variable cognitive outcomes. Short-term studies implementing time-restricted eating protocols document mixed cognitive effects that appear highly dependent on intervention specifics and individual factors. Some participants report enhanced alertness and mental clarity, particularly during fasting periods, attributing improved focus to stable glucose levels and reduced postprandial somnolence. These subjective improvements sometimes align with objective measures showing maintained or slightly enhanced performance on attention and executive function tasks. The proposed mechanisms involve both metabolic and circadian pathways. Ketone production during extended fasting may provide alternative neural fuel, while temporal alignment of eating with optimal circadian phases could enhance cognitive efficiency. However, a substantial subset of individuals experiences negative cognitive effects, especially during initial adaptation periods. Reports of difficulty concentrating, increased irritability, and impaired decision-making appear particularly common when eating windows are highly restrictive or misaligned with individual chronotypes. Evening types forced into early eating schedules frequently report afternoon cognitive decline, likely reflecting the compounding effects of circadian misalignment and extended fasting during their biologically preferred active periods. These negative effects may diminish with adaptation, though data on long-term cognitive trajectories remain sparse. The impact on mood deserves particular attention given the established relationships between dietary patterns and mental health. Time-restricted eating creates psychological challenges beyond simple hunger, the social constraints of limited eating windows, the cognitive burden of tracking timing, and potential anxiety about breaking schedules can all affect emotional well-being. Some individuals report increased stress and preoccupation with food timing, patterns that may indicate emerging disordered eating behaviors. Conversely, others describe reduced food-related anxiety through simplified decision-making and clear temporal boundaries. This bidirectional possibility suggests that psychological factors and eating disorder history should inform decisions about attempting time-restricted interventions. The emerging picture suggests that cognitive and mood effects of time-restricted eating likely depend more on implementation quality and individual fit than on the inherent properties of temporal restriction itself. Gentle transitions, chronotype-matched timing, and flexibility around social eating occasions may minimize negative cognitive impacts while preserving potential metabolic benefits. Individuals with demanding cognitive work, mood disorders, or histories of disordered eating should approach time restriction cautiously, monitoring mental performance and emotional state closely. The brain operates as both controller and target of circadian interventions, making cognitive outcomes as legitimate an endpoint as metabolic ones. Future research must integrate comprehensive cognitive and psychological assessment into time-restricted eating trials, moving beyond the assumption that metabolic improvements automatically translate to holistic well-being.